Welcome to BTEC Revision. In today's lesson, we're looking at centripetal acceleration. By the end, we're going to be able to calculate centripetal acceleration of objects. Centripetal acceleration is the acceleration acting on an object in circular motion. The units is similar to normal acceleration, which is meters per second squared. The equation is centripetal acceleration equals linear velocity squared divided by the radius. And the short form is A equals V squared divided by R, where A stands for centripetal acceleration, and V stands for linear velocity, and R stands for radius. The units for centripetal acceleration, as we mentioned, are meters per second squared. Linear velocity is meters per second all squared, and radius is meters. If we remember the equation for tangential velocity, V equals R omega, we can replace the V in centripetal acceleration with R omega. And therefore, that would give us R omega all squared divided by R. And simplifying this gives us R omega squared. And this is the second form of this equation. Centripetal acceleration is the acceleration acting towards the center of a circular motion. For example, if we have this circle here and we have some object, let's say a string attached to a mass, and we are swinging it around and around, there is acceleration pulling towards the center of this circle here. This is the centripetal acceleration. And this value can be calculated using the centripetal acceleration formula. Let's look at an example. A car travels in a circular path of radius 50 meters with a speed of 20 meters per second. What is the centripetal acceleration? We can start by writing down the equation. A equals V squared divided by R. And the speed is 20. That's squared divided by the radius, which it says is 50. Give us a value of 400 divided by 50, which is equal to 8 meters per second squared. Now pause the video here and attempt this exam question. The London Eye completes a full cycle in half an hour and has a diameter of 120 meters. Calculate the centripetal acceleration of the wheel. So we can start with writing down what we have. Diameter 120. So I think radius would be more useful. Radius is 60 meters. And we also have the cycle. And that's half an hour. So that's 30 minutes times by 60 seconds, which gives us 1,800 seconds. Next, we can write down the equation. So we have we have acceleration is V squared divided by R. And we also have acceleration equals R omega squared. So we can see which one we should be using. It's not this one because we don't have anything to do with velocity. So this is the more relevant one because we have angular speed here, which is equal to 2 pi divided by the time period. And you can see we have a full cycle in half an hour. So a full cycle in 1,800 seconds. And a full cycle is known as the time period. So this is our capital T value here for time period. We can plug that into the equation, give us omega, which will be 2 pi over 1,800. And then we can plug that in to the centripetal acceleration equation, which is A equals R, which is 60 times omega, which is 2 pi over 1,800 squared which would give us a value of 7.31 times 10 to the negative 4 meters per second squared.